Hi class, we're going to be doing lesson 2.2 and we're going to be talking about factors. A factor times a factor equals a product. And this is one of those times when knowing your times tables comes in really handy. So today we're going to talk about factors, and we're also going to break whole numbers into factors. And we'll try to find all the factors of certain numbers. We'll get some practice doing that. So if you want to go ahead and take your piece of white paper, and if you want to fold it into 3 hamburgers, just like we do for math, right? Hamburger, hamburger, hamburger. And I'm going to get my page set up looking really nice. I'm going to put some lines on it. And I'm going to do that on the back as well. Okay. So I'm going to go ahead and write my name up here in the corner, as I always do. And then I'm going to write lesson 2.2. And we're going to go from pages 56 to 61. All right. So we're looking at numbers and what factors they have. So if you look really quickly in the book, we have a picture of some soccer balls right here. And this is called an array. When you have a visual representation, these are all the same. And this shows 1 times 6. It means we have one group of 6, right? So we have one, it's 1 soccer ball wide, and there are 6 of them in a row. So this is a representation that shows us 1 times 6, right? Can 6 be divided exactly by 1? Yes. So 1 is a factor of 6. Can 6 be divided exactly by 6? Yes. So 6 is a factor of 6. 6 is also the product of 1 and 6, and 1 and 6 are factors of 6. Now there's other ways that we can show 6. In this picture, this is showing you turtles, right? And this is another representation. This is two groups of 3. If I count them all together, I get 1, 2, 3, 4, 5, 6. So this is showing 2 times 3. There's 2 rows, 3 across. 2 times 3 is 6. This is showing you 3 times 2, which is also 6. Can 6 be divided by 2? Yes. So 2 is a factor of 6. Can 6 be divided exactly by 3? Yes. So 3 is also a factor of 6. Can 6 be divided exactly by 4? No. 4 is not a factor of 6. Can 6 be divided by 5? No. 5 is not a factor of 6. So 6 is a product of 2 and 3, and 2 and 3 are factors of 6. So the factors of 6 are 1, 2, 3, and 6. Now I'm going to show you a way that I look up factors that makes it really easy, a little trick that I learned. So we're going to look at number 1 on guided learning. And number 1 says for us to find the factors of 32. So we have 32 equals 1 times 32. 32 equals 2 times 16. 32 equals 4 times 8. So that means the factors of 32, they have to go in order. We have a whole bunch of green boxes. We're going to put them in order. We're going to say 1, 2, 4. We're going to put commas between them. And they have to go in numerical order: 8, 16, 32. Okay, so I have to put them in order of least to greatest, or I call that numerical order, right? So this is not a prime number. It's called a composite number because it has more factors than just 1 times 32. And we'll talk more about prime and composite numbers next week. All right, and you're going to also make a little tool called a sieve of Eratosthenes that's going to help you figure out prime numbers and composite numbers. All right, let's look at number 2. So now we're listing all the factors of 24, and we have a lot of green boxes. We're just going to go in numerical order. We're going to start with 1. So 1 times what equals 24? Well, I would guess 1 times 24, right? Will 2 go in evenly into 24? Absolutely. 2 times 12 equals 24. How about 3? Will 3 go into 24? Yeah. 3 times 8, right, is 24. How about 4? Will 4 go into 24? Yes. 4 times 6. How about 5? Oh, absolutely not, because 5, this 24 would have to end in a 5 or a 0 for 5 to go in to divide evenly, right? So now we have a list of all the factors, and I'm probably going to write factors on here so that you get used to what this word is. So all of the factors, all of the factors of 24 are, we're going to put them in numerical order, remember? So we have 1, 2, 3, 4, 6, 8, 12, and 24, right? So those are all of the factors of 24. There are a lot of them. This is not a prime number. It has a lot of factors. If the only factors were 1 times 24, then it would be a prime number. But it is a composite number because it has many factors, right? One way to find out if a number is a factor of another number is to use division. So if you wanted to find out if 3 is a factor of 12, you could divide 12 by 3. If you wanted to find out if 5 is a factor of 16, you could divide 16 by 5. And you're going to find out it's not a factor, right? So we're going to find the factors. We're going to do, I think we're going up until, let's go up until, let's cut this and we'll say we're going to go to page 59, because I think there's a lot of work on this page. So let's make that page 59 that we stop at, okay? All right, let's look at number 3. Number 3, they're just giving us a number. And they're giving us a number and they're saying find all of the factors of 12, right? So if we want to find all of the factors of 12, we're going to start out with 1 times 12, right? Then will 2 go into 12 evenly? Yeah. So we're going to next have 2 times what equals 12? 2 times 6, right, equals 12. Will 3 go into 12? Yes. So 3 times what equals 12? 3 times 4, right? Will 4 go into 12? Well, we already did that one because we know that 4 times 3 equals 12. So we've just found all of the factors of 12. We're going to put them in numerical order. When we do that, we go in order 1, 2, 3. So I'm just going in order 1, 2, 3, 4, 6, 12. Right? So those are all the factors of 3. that number is not a prime number. It's a composite number because it has a lot of factors. If a number if it just had 1 times 12 as its factor, it would be called a prime number. But it has many factors. Okay, let's look at number 4. Number 4, they've given us 28. So our magic number is 28. So I'm always going to start out with 1 times the number equals the number, right? Now this ends in an 8, and it's an even number, so I know that 2 will go in evenly. So 2 times what is going to equal 28? 2 times what? If I divided each one of these by 2, what's 2 divided by 2? 1. What's 8 divided by 2? 4. So I think 2 times 14 is going to equal 28. Will 3 go into 28 evenly? No. Sometimes what you can also do is you can use a times table chart to do this. And a times table chart really helps. I'm going to get one of the name tags that I bought for you guys. It has a times table chart on it, and I will show you how to use the times table chart to find a factor. So if you have a times table chart, it can help you to find factors. And I just happen to have this little chart right here because I bought you guys name tags. So we will borrow a name tag. And this has a times table chart on it, which is very handy. Unfortunately, it's also very shiny. So I'm going to cut this part off. And then we won't have to worry about the other part of the times table chart. So if I want to find 28, one way to do that, the factors of 28, is to look on here for 28 in each row. I'm not seeing 28. Oh, there we go. 4 times 7. 4 times 7. So I know 3, it doesn't go into 28 evenly, but 4 does. So I'm going to say 4 times 7. And then I'm going to go to my 5s. No. 6. No. 7. Well, we got 4 times 7 already. So I just found all of the factors, and I used a times table chart to do that. It's very helpful to use that to find factors. So I end up putting them in order. I'm going to go 1, 2, 4, because I just follow in numerical order, right? 1, 2, 4, 7, 14, and 28, right? And those are all the factors of 28. 28 is not a prime number. Again, there are more factors than 1 times 28. If we only had 1 times 28, it would be a prime number. Okay, let's look at number 5. We have 56. Can you tell the numbers are getting bigger? Dun, dun, dun. Always start out with 1 times 56 equals 56. I think 2 will go in evenly, right? Because this is an even number. So how many times will 2 go into 56? What do you think? 2 goes into 50 25 times, right? And then we add 3, so 25 plus 3 is going to be 28. How about 3? Will 3 go into 56? Well, look, my times table chart only goes up to 36. So I can divide to figure that out. I can go like this and I can say, will 3 go into 56? Well, 3 goes into 5. It goes in 1 time, and that's 3, and I subtract, and I get 26. 3 doesn't go into 26 evenly, so I know 3 doesn't go in. Will 4 go into 56? Let's try. So sometimes you can use division if your times table chart isn't large enough, or if you don't know your math facts well enough, or if you don't know your math facts and you don't have a times table chart. So 4 goes into 5, it goes 1 time, we subtract 4, we get 1, we get 16. Ooh, it does go in evenly, so it goes in 14 times. So I'm going to say 4 times 14 equals 56. Now, 5 will not go into 56. I see right here that it goes in 55 times with 11, right? 6 does not go into 56 evenly. 7 does go into 56 evenly. 7 times 8. So I'm going to write on here 7 times 8. And then 8, well, I already did 8 times 7, so I'm all set. So my factors are, again, we're putting them in numerical order. 1, 2, 4, and 7. 1, 2, 4, 7, 8, 14, 28, 56. Okay? So you can always use division to figure out factors. This is a composite number. Again, if it were a prime number, it would only have 1 times 56 as the factors. Now we're going to do a hairy, scary one. Are you ready? They're asking us to find the factors of 100. All right, here we go. 1 times 100 is our starting point, right? This is kind of the logical way to set it up, too. I love this math program because it really thinks things through really clearly and logically. I don't know if you guys have heard the story of our math program, but this math program was created in Singapore. Singapore is a country. It was a country that really was struggling. They were failing on all the worldwide math tests. They were just really struggling. And so they sent spies out to all the countries around the world to watch how people taught math. They sent spies to classrooms in different countries: Peru, Sweden, United States, Canada, Germany. They just sent spies to all different countries that they could think of, and they watched how people taught math, and they picked all the best, most logical, clear strategies for math. And that's why this math program is so rockin', because they picked all the best ways of teaching. So it's really good. They have really good practices and good ways of thinking logically. If I'm thinking of 100 and I divide by 2, I'm going to get 50, right? So 2 times 50 equals 100. How about 3? Will 3 go into 100 evenly? I don't think so. Thinking about money, if I have $1 and I divide by 3, it doesn't go in evenly, right? But then I can say 4. I have 4 quarters. 4 times 25 equals 100, right? 5 will go in evenly. So 5 times 20, I can have 20 nickels in $1. That's going to equal 100. 6, will 6 go in evenly? I don't think so. I don't think 6 is going to go in evenly. 7, will 7 go in evenly? No. 8? No. And again, you have your times table chart. I'm kind of peeking at it. So if I'm here at 7s, I don't think it's going to go in evenly. I know 8's not, because if 8 times 12 is 96, it's not going to go in evenly to 100. How about 108? No, on 9. How about 10? Yeah, 10 times 10, right? So I'm going to go right here. 10 times 10 equals 100. So my factors, again in numerical order: 1, 2, 4, 5, 10. 1. I also like to write on here factors so that I know what I'm doing. This is 1, 2, 4, 5, and 10. And then 20, 25, 50, and 100. Okay, so those are all the factors of 100. Definitely not a prime number, definitely a composite number because we have a lot of factors here, right? Okay, now we're going to look at finding common factors of two numbers. So we're going to pick two numbers and we're going to find the factors that they have in common. So if you're looking in your book right now, what you can look at right here is if we have two numbers, let's say we have 8 and we have 12, we can find the common factors of 8 and 12. So the factors of 8 are 1, 2, and 4, and 8. The 12 are 1, 2, 3, 4, 6, and 12. Which ones do they have in common? The ones that are circled in green, right? Those are called common factors. And a common factor is a factor shared by two or more numbers. Now on number 7, they're asking us to find the common factors of 9 and 36. And they've listed them for us. So I'm going to put the list a little bit neater on number 7 so that we can stack it. So the factors of 9 are 1, 3, and 9. The factors of 36 are 1, 2, 3, 4, 6, 9, 12, 18, and I'm just looking in the book right now, and 36. So up here I can circle them, or I can use a highlighter, right? So I can take a highlighter and I can go, well, they have, the ones that they have in common are 1, 3, and 9. Okay, so the common factors are 1, 3, and 9. Okay, pretty easy. The trickiest part, I think, is they did for us, the finding the factors part. Figuring out the ones that are in common, you just have to compare the two and see which ones match, which ones are the same, right? Common means same. Okay, let's look at number 8. We're going to do 8, 9, 10, 11, and then I would like us to actually to skip some of the ones that are, I would like us to skip 12, 13, 14, 15, and I really want us to do 16, 17, 18, and 19, okay, on that page. So we get to skip a few of the easier ones, and we're going to do the trickier ones together. So let's look at 8. It's asking, is 5 a factor of 20? So let's make our chart. Here's 20. 1 times 20 equals 20. 2 times 10 equals 20. 3 doesn't go in evenly. 4 does. 4 times 5 equals 20. So is 5 a factor of 20? Yes. Bloop. Right there. That was easy. All right, now it's asking us, is 5 a factor of 35? So let's find our factors of 35. 1 times 35 equals 35. 2 will not go in evenly to 35 because it ends in an odd number. 3, will 3 go into 35? No. Will 4 go into 35? No. Will 5 go into 35? Yes. 5 times 7. 6. Will 6 go into 35? No. Goes into 36. And then here's 5 times 7 again. So we're done. So is 5 a factor of 35? Yes. Yes. Okay. Next, question number 10 says, is 5 a common factor of 20 and 35? Well, here we go. Let's find 20. Let's find 35. So for 20, we have 1 times 20. We have 2 times 10. We have 3 doesn't go in evenly. 4, if we're using our times table chart, 4 times 5. 6 doesn't go in evenly. 7, no. 8, no. 9, no. 10. So we're good. Those are just all of the common factors. Now let's see if we do 1 times 35, right? We did both of them over here, so we can just copy it. This is 5 times 7, right? So is 5 a common factor? Yes. Both of them had 5 and 5. So we're going to say yes. You can point a little arrow to both the 5s, right? Okay. Number 11, is 2 a factor of 24? Well, let's find out. 1 times 24, 2 times 24, 2 times 12. Will 3 go into 24? Yeah, there's 3 times 8 is 24. 4 go into 24? Yeah, 4 times 6. 5 doesn't go in evenly. So they're asking us, on number 11, they're saying, is 2 a factor of 24? Yes. Okay. So one of the things that we really want you to do this year is to get really good at your times tables. Third grade was the year when you were supposed to pass off your times tables, and sometimes that doesn't happen. So you are going to definitely pass off your times tables with me. And I have times table pass off cards. This is why we pass off times tables, because you should be able to just do this without using a chart. That being said, there's several people always every year that have to use a chart, and that's why I'm showing you how to use a chart. But by the end of 4th grade, this needs to be inside of here. It needs to be in your brain, right? Unless you decide to get a tattoo of this on your arm so that you can peek at it all the time when you're doing fractions and factors and dividing, which I don't think you want a tattoo times table on your arm. So we're going to look at number 16, and number 16 says 32. It says find the common factors of 32 and 12. So we're going to do that. Did we already do 32? No. So we're going to have to start from scratch. 1 times 32. I know that 2 is going to go in evenly, right? Because this is an even number. So if I cut 30 in half, it's 15. So if I add 1 more to it, it's going to be 16. And 2 times 16 is going to be 32. Will 3 go into 32? No. 3 goes into 33. 3 goes in 11 times to 33. How about 4? 4 times 8 is 32. So we're going to put 4 times 8. 5 won't go into 32. Here's 30 and 35. And 6 won't go into 32. Here's 30 and 36. 7? No. 28 and 35. 8? Well, we already did 8. So there are our 6 factors of 32. Now let's do 12. 12 is going to be easy. We should know our times tables. 1 times 12, 2 times 6, 3 times 4. That's it, right? So we're looking for common factors. Well, we have 1. We have 1. What else? 2, they both have 2. 4, yeah. I'm not seeing anything else in common there, right? So I think it's just 1, 2, and 4. Okay, let's do 17. 17 is going to be easy because look, we're doing 12 again. We already did 12 last time. Bless their hearts. Now we're doing 16 over here. So we're going to do 1 times 16, 2 times 8, 4 times 4, and we're done. So let's see what we have in common. 1, 1, 2, 2, 4, 4. No 8s, nothing else. So our common factors are Our common factors are 1, 2, and 4. Same ones. That's spooky. Okay, let's do 18. 18, we have 60 and 54. It's going to be a little bit more challenging because the numbers are bigger. So let's do 60. And I have my times table chart handy for extra help. So I'm going to do 1 times 60. I know that 2, if I cut 60 in half, I get 30. 3 will go into 60 because 3 goes into 6. So I'm going to say 3 times 20, right? Will 4 go into 60? 48. 48, that's 12 times 4. Let's double check it down here. Let's go down here. 4 into 60. 4 into 6, one time. Ooh, I'm glad we checked. 15. 4 times 15. I know 5 will go into 60 12 times. 6 goes into 60 10 times, right? 7, no. 7 goes in 63, but there's no 60 down here. So I think that's it. Now let's look at 54. So we have 1 times 54. I know 2 will go in because this is an even number. So let's see. If I cut 50 in half, it's 25. If I cut 4 in half, it's 2. So 25 plus 2 is 27. That's how I do that. I just cut each number in half by place value. Cut 50 in half, cut 4 in half, and add the halves together. Will 3 go into 54? I don't know, and that's not on our times table chart, so I'm going to try it down here. 3 goes 1 time, subtract. Ooh, it does. 18. So 3 times 18. Will 4 go into 54? I don't know. 48 plus 4 is going to be 52, so I don't think so. 5 won't because this should end in a 5 or 0 if it's divisible by 5. 6 will go into 54? Absolutely. Right here on my times table chart, 6 times 9 is 54. And then that's it. I don't see any other 54s. I see 56s. Right? Oops. Sorry. Sorry about that. My sister's calling me. Let's see. 7, no. 8, no. 9. We're already here at 6 times 9. So let's figure out which ones we have in common. We have 1 and 1, 2 and 2, 3 and 3. No, 4, 6 and 6. 9, no. 10, no. 54, no. So none of those are in common. So we're going to say common factors are 1, 2, 3, and 6. 1, 2, 3, and 6. And because I've done a whole bunch of messy division, I'm going to go like this. so that my old lady teacher can really see what my common factors are, right? Okay, last one is a face melter. Are you ready? 45, dun, 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 and 96. Ay caramba. Okay, so we have 1 times 45. 2 won't go in evenly because this ends in a 5. It's not an even number, right? 3, I know 3 will go into 45. I just have a sneaking feeling, so I'm going to do that right over here. I have a sneaking feeling, but I could be wrong. 3 into 4 goes 1 time. 15, yeah. 3 times 15. 4 doesn't go into 45 evenly, right? It goes 44. 4 times 11 is 44. I see 45 right here. 5 times 9. 6, no. 7, no. 8, no. It's 48 and 40. 9, we already did that. So 45's done. Now we're doing 96. So I'm going to do 1 times 96. I know that 2 will go in evenly because it ends in an even number. So if I cut this in half, if I cut 90 in half, I would get 45. If I cut 6 in half, I would get 3. So I'm going to do 45 plus 3 is 48. 2 times 48. Does that make sense? I know 3 will go in evenly because 9's divisible by 3 and so is 6. I think it's going to go 32 times. 4. I don't know if 4 is going to go in. Let's give it a try. This one's evil. It does. 24. So if you don't know, you can always do a quick little division problem, right? If you're not so good with your times tables, this is the time to climb on board and start learning your times tables, because this gets to be, we do a lot of this kind of work where you should know your times tables. That's why I'm saying that times tables should be learned by 3rd grade, because it's a 3rd grade skill. So if you're a little bit behind and you don't know your times tables, this is the year you're going to bust a move and learn them, right? I can help you. We'll help you pass them off every Friday until we get them all passed off. So will 5 go into 96? No, because this would have to end in a 5 or a 0, right? 6, I don't know. Will 6 go into 96? Let's check and see. Our times table chart only goes to 72, so I'm going to divide. 6 will go into 9 once, with 3 left over. Oh, it did. 16. 6 times 16. I'm glad we did that. 7. I don't know. Let's see. 84. If I add 7 more to 84, am I going to get 96? No. 8. 8 times 12 gives me 96, right? I'm looking here on my times table chart. 8 times 12. Okay, so I think let's look at 9. I see 9 as 90 and 99, so it doesn't go in evenly there on any of the others. Oh, and here's 12 times 9, so we know. 8 times 9, sorry, so we know that we've hit our limit. Okay, so let's look at which ones they have in common. 1 and 1, 3 and 3, not 5. 9, no. 15, no. 45, no. So the only ones they have in common are 1 and 3. That's crazy. We did all that work just to find that out. Harumph. Harumph. Okay. So I hope this kind of helped you figure out what factors are. One thing to remember is a factor times a factor equals a product in math, right? This is math language. A factor times a factor equals a product. So we're talking about multiplication. An addend plus an addend equals a sum, right? So that's addition language, but we're using factor times factor equals product, right? There's also division language too. This year you'll learn about divisors, dividends, and quotients. But for right now, all we're going to really worry about is factors. A number times a number that equals a product. In this case, this number we circled that we were looking for is always the product, and we're just figuring out what numbers we can multiply together that are going to equal that product, that particular product. So that is learning about factors and about common factors. Later on, when we do the next part of the lesson, we're going to learn about greatest common factors. They are nicknamed GCFs. And I think you'll like finding them. They're pretty fun. All right, I hope this helped you to learn about factors, and I will talk to you later.